Welcome to Kenton's videos. Enjoy the video.
You start by picking a fixed control volume V with boundary S and outward normal N. Define the local density rho, x, t, and velocity field v, x, t. Now express mass conservation. The time rate of change of total mass in V equals minus the net mass flux out through S. Compute the volume integral of rho over V and the surface integral of rho Vn over S. Once set, prepare to convert surface flux to a volume integral so you can combine terms. You now convert surface flux into a volume integral using the divergence theorem. The surface integral of rho Vn becomes integral V, rho V dV. For a fixed control volume, you move the time derivative inside the integral. d/dt integral V rho dV equals integral V delta rho / delta t dV. Combine the two volume integrals so that integral V delta rho / delta t plus rho V dV equals 0. Make sure you keep signs consistent. The result must hold for every V. You conclude by invoking the fundamental lemma. If integral V dV equals 0 for every V, then the integrand must be 0 pointwise. Thus you get the continuity equation delta rho / delta t plus rho V equals 0. Once done, note the special case. If rho is constant, pull it out to get V equals 0 for incompressible flow. If your algebra fails, check the normal orientation sign and application of the product rule when expanding rho V. Those are the
Thanks for watching. Consider subscribing if we helped you.